So hi everyone, this is Maurizio, editor of Power Electronics News and European correspondent for E-Times. We are here at the Power Electronics Conference in Munich, and I am here together Anup Bhalla, engineer at United Silicon Carbide. Hi Anup, how are you?
Nice. Thank you.
So the power market is changing a lot. We have in a new year about wide bandgap semiconductor. Just to focus on silicon carbide, can you tell me the the advantages for silicon carbide? Why SiC?
Well, you can see that silicon carbide devices, especially at voltages over 600 volts, 600 and 1200 volts, are providing devices that make your converters far more efficient because you can get much lower switching losses together with lower conduction losses, and this is enabling a wide range of applications, such as for EVs, onboard chargers, DC-DC converters. Now people are looking at traction inverters, so on.
So for engineers, I think that there are many parameters that should be considered for a designer. So for example, RDS on. Why it's important to have a lower value for that? In which application is more important to have lower value?
Well, so designers have to consider many things when they design with power electronics, RDS on, and also the switching losses. Uh, These switches are used in two modes. They're either conducting current or they're transitioning from the on to the off state. And when you're conducting current, you don't want to have to, if you have high RDS on, you will have high losses, which you have to then heat sink and remove the heat. So you want to have low RDS on for that reason. And usually there's a trade-off in a device. If you have low RDS on, you tend to have high switching losses as you transition from on to off. So that's not good either, especially if you're running at high frequency. So these are tough choices, but silicon carbide has really improved this trade-off for power devices.
Yeah. So about your market, in which market are you pushing now? Which are your latest products?
So we've got some very low RDS on devices available, very high frequency switching devices available. The 650 volt devices we have, can be used in the EV market, but they can also be used in the computer server power supply market, or the telecom rectifier market for 5G telecom rectifiers. 1200 volt devices are used in onboard chargers, DC-DC converters, in the future in traction inverters, but you find them in the solar business, in energy storage. And these very low RDS on devices we have recently launched, they're good not only inverters, but you can now consider them in solid state circuit breakers because the conduction loss is so low that you parallel a few of these devices, it's almost like you will generate no heat.
So how do you see the future for power?
Well, as with all other semiconductors, we improve our technology year after year. So every 2 to 3 years, the on resistances will basically halve for a given chip area, right? So the technology just keeps getting better. This simultaneously drives down costs, and this whole thing, enables new applications as time goes by. So on top of all the applications I'm describing to you, I think with every 2 or 3 years, you'll see more people will think of new things to do with these devices.
That's great. Thank you so much, Anup.